Hello, welcome to Online Skill India, a growth in you through our coaching technique. My name is Tirupati Naik, a Parametric Solution Private Limited company. Our tagline is wisdom, satisfaction and happiness. So we're going to learn on CNC programming. CNC stands for Computer Numerical Control, a professional engineering course. Programming on VMC, Vertical Machining Center on Fanuc control. So here we can see the drawing and the program number is 6. Earlier 5 programs you can watch on our video. G and M code toolpath generating. So this is a workpiece of rectangular 70 by 50 mm by 10 mm. Here we are going to do the profile of straight and then radius, again straight, radius, straight, again radius, and then straight and radius. So that's the starting point. So this is a profile which we are going to use, and by using a subprogramming. Okay, this is the origin. From origin, the starting point is 10 mm in x direction, y direction is 12 mm, and z direction is 1 mm height. So this is the workpiece, and we're going to start the program. So by using a tool cutter compensation, the Ford used G41, the tool nose radius compensation towards left side, and G42 is a tool nose radius compensation towards the right side, and G40 is a tool nose radius compensation cancel. So that we are going to using in this with subprogramming and main program. So here we start the subprogram first. Okay, and this subprogram is always it is edited in the control panel. So now here this is the starting point, and from here the first point. Okay, now program name will be defined as O5522. That's in Fanuc control we edit in numbers, the numerical values, that is 4 decimal, and then a block number, that is N05, the first block statement which starts. Then G91 is a incremental coordinate system. Then G01 is a linear interpolation, and Z-1 is the depth of cut. So straight away I am from here 1 mm of height and moving inside in Z direction minus 1 mm depth of cut with the feed of 80 mm per minute. Then from here the tool which moves in this direction, second point in y direction, from here 0 point, this y distance is, this is 10 mm, and this is 10 mm radius, and then this 1 to 2 is 10 mm. So overall is the y distance is 30 mm. So the statement is N10 is the block number, and G90 is the absolute coordinate system, y30 is the distance from here to this point, and the feed is 100 mm per minute. Then after that I have to use the radius cutting. So here that is G02 is a tool towards the clockwise direction moves, and X 20 mm from here to this point is 10 mm, and the radius is 10 mm, that is X is 20, Y is 40, from here to this distance, third point is 30 and 10, that is 40 mm in Y direction, and the radius is 10 mm. So this is the complete block. Then we have this feed is applicable here also, that is F100. Next again from third to fourth point is the straight cut, that is G01 X50, from here 10 and this distance overall is 60 mm minus 10 mm, so it become an X50 mm distance, and the feed is 100. Again from here fourth to fifth point is the radius cutting. So in clockwise direction the statement is N25, that is block number, and the G02 then X is 60 mm, from here to this distance is 60 mm, this is 50 and 10, that is 60 mm in the X direction. Y direction is 30 mm, from here to this distance, fifth point is 30 mm, and the radius is R100, and the feed is 100 mm per minute. The next is again straight cut from fifth to sixth point. So here the sixth point is from here, this is 60 and 20. So G01 is a linear interpolation, Y is 20. and the feed is 100 mm per minute. So this is active in all the statement wherever we are linear or circular interpolation. Then next point is again from here it is a straight cut like G01 x 20 mm. Okay, so that's a 10 and this is 10. That will be x 20 in x direction and y is the 10 mm. And again the radius from the here 8th point to first point radius, that is G02, that is clockwise direction, x 10 mm, from here to first point is 10 mm and y is 20 and radius is 10 mm radius and feed is 100 mm per minute. And the program we are going to stop here for subprogram. Okay, the subprogram is always end with the M99. So this is the program of a subprogram. So it starts the tool from here and it ends at the same again point. So this is what we are learned about. Now this subprogram we are now taking into a main program. We're going to begin with the main program. Okay. So the main program here will start to go 3322. That's a program name. Then again N050. G17 is the XY plane selection in the milling machine, and G94 is a constant feed mm per minute, and G21 is a mm unit. The next step is the tool which is as a tool reference at home position, that is G28, G91, X0, Y0, Z0. The next step is the tool selection M06. Here I am selecting the tool T05, and then tool height compensation G43, and the tool height is 5 mm reference. Now after that tool selection, the spindle starts rotating at 800 rpm. M03 is the tool rotation in clockwise direction. The next step is this is the origin 00. Okay, from here the tool which moves from the S to 1 point. So here G56 is a workpiece 00. Offset is provided or given in the G56 in X, Y and Z. And then G90 is the absolute coordinate system. G00 is a rapid traverse, X minus 10. So from origin, this starting point is this distance is 10 mm given, and Y distance is 12 mm given, and Z 1 mm is the height from the workpiece, okay, above 1 mm, which is in the air. And then the M08 is the coolant on. The next step is that here I mentioned a G42 is a tool cutter compensation, okay, towards the right side. So and the D5 is the offset. So the tool is going to move inside and then takes. If it is G41, then if the tool moves outside this tool, okay, the profile accordingly. If it is in between, if you want to move the tool, then that is a G42 will not be used in that. Okay, so if the tool is moving from the profile outside, that is towards the left side, then G41. If it is moving towards the right side, then it become a G42 code. That is, this is the defined, and X 10 mm and Y 20. So from here, that is X is 10 mm, Y is here it is 20. Okay, so the tool which is moved from the home position to starting point, from here to 1 mm above, it's moved to the first point. From here, we're going to call a subprogram. The subprogram is always called from M98. And the program in the earlier page in slide which is mentioned is 5522 program we are calling, and that program is moved 12 times. What do you mean by 12? That is P12, and 5522 is the program number. This 12 times. So this program, the first program which is I have maintained in last page, it will move this way 1 mm thickness, again 2 mm thickness, like that. When it just goes to the 10 mm depth of cut, so that it will remove the throw cut, okay, inside. So that is about the subprogram. The use of this, that to lengthy of this program you can reduce in the one statement itself. The next step is after the 12 number of times it is going to be repeated. That's also called as a canned cycle. We call this also canned cycle. And after that, the last point M99, where it stopped the program in the subprogram. Here the next step is G90. With the absolute coordinate system, I am moving upward, okay, Z 1 mm. So here it will move from the minus 10 mm to, it moves to the 1 mm plus side. Okay. Then after that, from here the tool which moves to the minus 10 mm in x direction from the origin minus 10, and y is a 12 mm, and then z is a 1 mm, and then here spindle stop, that is M050, and coolant stop M09, and then the tool or turret, it moves to the tool reference, that is Z28, Z91, X0, Y0, Z0, and after that program stop, M30 code will be used, and then reset the program. Here we can see this is the workpiece of rectangular, and this is the vise, and this is the drill bit. Okay, so this is the program what we learned about the subprogramming, and then main program and cutter compensation. The program what we learned about subprogramming. So we're going to run in the simulation so that this program is right. We will confirm that. Okay. So here we can run this program. I already edited towards this editing. So this is the starting point. Second point, radius, again straight cut. Then again radius. Then again straight cut. Then again radius, and then straight cut. Again radius, and ends at the first point. So you have learned today about the profile cut with the subprogramming method. Thank you so much for watching our video.